Students, welcome to this lecture number 10 on ionic equilibrium. In this lecture, we are going to discuss the acid-base titration indicators. When we are performing the titration, that is the neutralization of the acid and bases, it is very much necessary to know its endpoints and visibly you will able to understand in endpoints if there is a probability, is there is the facility of some indications, and these indications may has been studied and has been introduced with the form of indicators. So in this lecture we will try to understand what is basically how the indicator is basically working and what is the indicator and what is the pH during that time when the indicator perfectly shows the color and we understand its endpoints. So today's lecture is the indicators of acid-base titrations, or we can say acid-base indicators. Okay. So this is KK Mukherjee in the Science with Mukherjee Sir YouTube channel. So let us understand what is acid-base indicator. What indicators, how indicators going to display the colors when the titration has been completed, when the neutralization of the acid and base has been completed. There is a theory by Ostwald, Ostwald, that is a great scientist. Ostwald say a very important thing that about this acid and base. Basically indicators. Ostwald say that indicators are basically a weak acid and weak base having a complex molecule. If you study the structure of the indicators, molecules of the indicators, this is basically acid and base and having a very complex structures. We are not going to understand this structure. We are just want to know how the indicator is going to display the color, but how they changes the color. So we can say the acid base indicator, acid base indicator are weak acid and weak bases of complex molecule. Acid base indicator are basically weak acid and weak base. Let us have two very important popular indicators. That is number one, that's methyl orange. Methyl orange. Methyl orange is a weak base and we will denote it as MEOH, methyl orange. And second indicator that we are going to discuss, it is phenolphthalein. Phenolphthalein. It is an acid. It is a weak acid. Phenolphthalein is a weak acid and the methyl orange is a weak So what is there, let us understand. When it dissociates in the aqueous solution, its equation will be written like this way. This is the equation of this. When it is dissociated and produce the ions in the aqueous solutions, the ions having a different color, and that is a catch point that you are using it is as an indicator. So methyl orange has undissociated methyl orange of the yellow color. When it is dissociated and it is a cation, it will have the pink color and it is colorless. OH minus is colorless. So you can easily understand that when it is being dissociated and produce this ion, and the ions will having some color. That is, we see that is when it is the methyl orange, when it is undissociated form, it is of the yellow color. When it dissociated form, it will have a pink colors. Similarly, for phenolphthalein, it is the acid. So we write this. We write this dissociation equations is like this, aqueous and this H plus aqueous and the pH minus aqueous. Here also you can see there is a color changes. This is white color. White color. Here it is white color change. Now you can say colorless. You can write this colorless. Colorless. This is also H plus ion, do not have any color. Colorless. But this pH minus, that is anion produced by upon the dissociation, it will have the color that is red color. Okay, that is how the indicator performs. It is basically a weak base, and when it has been dissociated, it will giving a different color, and that is these things have been utilized during the titration reactions, that you will be able to understand when it is titrating, when that acid changes its color, that when you change the color, you will feel that whether it is reached the end point or not. For methyl orange, if you see, if we put some acid, means we are giving the H plus ion. So as per Lachatelier's principle, you can recollect, we have already discussed in our chemical equilibrium lectures, that when you put H plus ion, what is going to happen? That this will react with OH minus ion, and this OH minus ion will be vanish. So naturally the reaction will goes in the forward direction. So more MeOH, that is methyl orange, is going to be dissociated and it will produce this pink color. So when there is a acidity, when this medium has changed, the acid medium comes, at that time what is going to happen, this methyl orange will dissociate and it will produce the pink color, because this Me plus will be the higher amount, and this will give the change in the colors. So when it is acid medium, the methyl orange yellow become pink. Okay. When we put the OH minus ion, what is going to happen? The OH minus ion is become surplus. If it is surplus, what we try to do this reaction, which is in equilibrium, it will proceed in the backward direction and it will produce the yellow color. So what what is there in the basic medium, that is in the right. This is very important thing to understand. In acid medium, methyl orange color will be pink, and in the basic medium, methyl orange color will be basic medium, it will yellow, because the reaction equilibrium has been shifted to the right direction, because you have put more OH minus ion, and this OH minus ion has to be consumed, and that is only one way that you can able to consume, by making these reverse reactions. So when there is a changes in the you can see the acid, that is a medium, changes from the acid to the base, it will going to create this type of changes, and from these changes you can able to understand whether there is the titration, in which point the titration is there, which is in the hub end point or in the end point. Similarly, in case of this phenolphthalein, you can see also this type of trend. It basically colorless, and it when dissociated, its anions will give the red color. So when we put this H plus ion, what is going to happen? The reaction will reverse in the reverse direction. So you can write this is in the acid medium. This phenolphthalein will show the colorless, and when it is in the basic medium, what is going to happen? The H plus will consume, so reaction will goes on the forward directions, and it will become, in the basic medium, it will become your red. The basic medium, it is red color, and the acid medium, it is a colorless color for this phenolphthalein. This is for the phenolphthalein, and this is for your methyl orange. So now we try to understand the indicators, you understand how the indicator works. And point is, this indicator can we use for every type of titration, because there is different type of titrations. You can see that is one titration, that is strong acid plus strong base. Second, strong acid plus weak base. Third, weak acid, strong base. And fourth, that is weak acid plus weak base. This is the fourth type of situation you can arrive. At that time, which type of indicator you will use? Again, that is the point of consideration, point of understanding. What we will do at that time? For the strong acid, strong base, what is there? You can use any type of indicators. You can use this phenolphthalein, you can use the methyl orange. But if you see it is a weak acid and strong base, at that time what we will use? What we will use, that is again a very important point to understand. When it is the weak acid and weak base, what is going to do? With the strong acid and weak base, what will go to this? So at that time, what we will do? For this, we have to see the pK value of this acid and base. For methyl orange, its pK value, its pK value is around 3.47. So it will be used at that time when there is a strong acid and weak base. At that time, we will use the methyl orange. When it is weak acid and strong base, then we will use the phenolphthalein because its pK value is around 9.2 something. So at that time what we are going to use, we have to use the phenolphthalein. Right? Because the color changes, when the color change will happen, there is a particular pH, at that pH only there will be the color changes. That can we understand from this discussion. Now we are going to discuss in which pH this will going to activate and what are the factors that will determine the pH. For this methyl orange and for this phenolphthalein, there is a different type of things. Okay, now so from this this is a very important information that which type of indicator you will use for different type of titrations. For strong acid and strong base you use methyl orange and phenolphthalein, or any type of indicators you have bromothiamol or methyl red you also can use. Weak acid and strong base you will use the phenolphthalein, bromothiamol blue and methyl red. For strong acid and weak base, already we have discussed the methyl orange and this. And weak acid and weak base, the bromomethanol blue. So you can see how they are using this. This is basics on the basis of this their pK value. If the pK value is the pH range, that will determine pK value will determine the pH range in which pH range they are going to display the colors, because we are much more interested on the color changes at the appropriate time, so that you can able to understand how the indicators going to perform, how the indicators going to say about the end point of the titrations. So already we have discussed that this is its pK value is 9 point something. So and its pH range will be like this, 8 to, if pH range will 8 to 10. So we must use for the strong base and weak acid. For the strong acid, because methyl orange had the pK value we have already discussed, that is 3.47, and its ranges from 3.8 to 4.5 pH. This is the pH and this is. So we will use this strong acid and weak base. For that we will use methyl orange because its pK value is this. Now we are going to discuss how we can say this pH value will, which pH value the indicators are going to perform well. That we will going to see from a numericals. From this numerical, you can able to understand how the pH works. Mathematically, you can able to see. An acid type indicator. This is a acid type indicator, and we have put the H. The hydrogen will be dissociated after this. Differs in color from its conjugate base. We know when acid dissociated, this is going to give the conjugate base. Conjugate base, that is this, and minus. Then human eye is sensitive to the color difference only when the ratio of this and this is greater than 10 or smaller than 1. When it is greater than 10, when it is in the, suppose this is the acidic medium, so let us see its dissociation. Understand its dissociation, H plus, I minus. So its K value, K indicator, equilibrium indicator, that is given by this H plus and I minus concentration of this. This is the molar concentration of this, and you will get H I N. So when this ratio will greater than 10 or this ratio is less than 1, then there will be that changes of the pH, changes of the color you will find. So at that time, which will be the pH change, that we have to understand, and K value for this dissociation constant value has been given. You have to do this. So for this, what we will do? First we have to see that this from this H plus ion, we will get the K indicator into this H ion divided by this. This is the concentration of the hydrogen, and this is your equilibrium constant of the indicator, and you will see that is the acid, concentration of acid and concentration of this conjugate base. So it has been given there. So when it is greater than 10, so you can understand the concentration is here very important thing. When the concentration of this will changes, it will going to affect the color changes, and human eye only sees at that time when this ratio is greater than 10, and when this ratio is less than 10, means when it is in the acidic medium, when is it we are getting this acid, at that time what is going to happen? Now this concentration will increase and this will be decreases. So at that time the smaller than this 0.1 will applicable, and when we put this OH minus, when we give the alkali color, alkali medium, at that time this ion minus will be increases and this will be greater than 10. That at that time you have to see what will be the pH change. So you can understand that is the H plus, then the K value has been given here, this 10 to the power this. So we can see, you can write this minus log of H plus ion is the pH, that is the pH. So you can get this minus log of K ion equal to minus log of so when this will, we put the value is here, you can see that is it is coming around 5. When put this value is coming of 5, and this is the pH value. Now this log you can see when it is greater than 10, when it is greater than 10, so we can write it is log 10. Log 10 is means that is 1, so it will be 4. At that time when this value, that is concentration of H ion by concentration of this is 10, at that time this pH value will be this. Okay. Now second case, pH value will be 5 minus log of 1 by 10, means it will coming around 6. When the concentration of this H ion by this concentration, acid by the conjugate base, this will be 1 by 10. At that time we get the 6 value. So at that time what is going to happen? The pH is going to be changes from 4 to 6 means there is a ranges in the plus, this ranges of the 2. So 2 will be the right answer. You can understand that pH will change from 4 to 6 for this acid having this K value, and at that time you will only change the color. Color will be visible to you. You can able to identify this color during the changes of the titration at that time. Okay, I think that is clear to you. And that is all for today's lecture. In the next lecture, we will discuss the solubility product, and that will be the last lecture on this ionic equilibrium. Hope you enjoying all these lectures, and I think it will be very much helpful to you. If you like this video, you can share to your friends. Thank you very much for watching. Thank you.